Hello and welcome to R&D Mathematics. Today we are going to learn some applications involving quadratic functions. Application involving quadratic functions. Now, actually, let's see some examples. That's the best way to do it. Now, first one, let's say you have 500-foot roll of fencing and a large field. You want to construct a rectangular playground area. Okay, so the first thing you need to do, draw some figure. I'll draw a figure. Let me draw a figure over here. Rectangular area, so maybe it looks like this. And what are the dimensions of the largest? Okay, so what are the things that you know? 500 or so. This total is 500. So we need some variables. You can go with x and y, or you can go with L and W, length and width, whatever is comfortable. So you know what, let me go with L and W. L for length, W for width. So this is W and this is L as well. Now the first thing that you know, 500 is what? L plus W plus L plus W. So 2L plus 2W equals 500. Or if I divide this by 2, I get L plus W equal 250. That's the first thing we know. And what are the dimensions of the largest such yard? See, this question, before I proceed further, let me show you. See, area, you know, area. See, for example, you can have 500, let's say 200 and 200, that's 400. So you have 100 more, that's 50. So in this case, area is 200 times 50, which means 0, 0, 0, 10, 10,000. And you may have like 150 and 150, that's 300. Then you need 100 and 100. In that case, area is 150 into 100, which is okay, 0, 0, 0, 50. See, this area is larger than this area. So like that, depending on the numbers, you get different areas. So what is the largest possible area? Okay, I think now the question is clear, right? Using your knowledge, there is a way to attack this problem. Actually, using calculus, also there is an easy way, but we need some advanced theory parts. But using quadratic functions, we can easily solve this. Now, next thing, you have to write down your equation. So, A is going to be L times W, right? That's the area of a rectangle, length into width. Now, what you need to do, since you have two variables here, this is first, let's call that first equation and this second equation. I would like to make second equation into one variable equation. So from 1, I will solve for W. W is going to be 250 minus L. And I will plug this in 2. So I will get A equals L times 250 minus L, which is minus L squared, if I write down the square term first, plus 250 L. So this is a function of L. So A of L, exactly like say f of x is a function of like that. Now variable is L. So as the L changes, the area changes. L squared plus 250 L. Now this is a quadratic function. That's the thing to know. This is a quadratic function. And in general form, so what are A, B, and C? A equals -1 because negative L squared. B equals, sorry, here 250. B equals 250 and C equals 0. Now, because this is a quadratic function, and look at this, A is negative, because of that, it opens what? It opens downward. Because it opens downward, you have a maximum point. right? Because it opens downward, you have a maximum point. If it opens upward, you are having a minimum point. But no, in this case, you are having a maximum point, and it nicely makes sense. Question asks you the largest possible area. Now, can you remember? So this vertex formula was negative b over 2a, and function value of that value, you put it here. So vertex negative b over 2a, let's see. So vertex, so max occurs at, that's our vertex, right? So v equals negative b, so negative 250 over 2a. 2a is negative 1, so negative 2. So when you divide, negative cancel, you have 125, and f of that value, but here we have a of that value 125. Now we are almost done. So our length is going to be 125, and if the length is 125 by 1, it's clear w is also 125, right? Because L plus w is 250, and the required maximum area, now let me erase this part over here and write it down. So the required maximum area is a times 125. See this value right here, because that is the that is the y value of that maximum value, and you can easily find that L times W. So 125 and 125, you can multiply that. Five, 2, 1, and see this is the, so foot squared. This is the largest possible area that you can get. Okay, I think you understood that well, right? If you have any questions, you can leave a comment. And let's go to the next one. I chose some different kind of problems. So find two numbers which have difference 7 and a product that is minimum. Okay, first of all, we have to understand this question. So two numbers which have difference, so see 8 and 1. Difference of 7, which makes sense, right? And the product in this case, 8. If I choose 4 and 11, and the product 44, see? And if I choose 9 and 2, product is 18. See, like that. You may think it's 8, but we don't know. We have to check. So there are infinitely many choices to choose two numbers with difference 7, right? But in such a way, their product is minimum. See, this is the power of quadratic functions. Now let's address this question. Now you cannot draw anything, because this is not a practical kind of application. This is more number theory application. So this is how you start. Let x and y be the two numbers. Now x and y cannot be the same, because if x equal y, the difference is 0. So without loss of generality, we can assume one number is larger than other. So we have x minus y. See, this is without loss of generality. So x minus y equals 7. That's the first thing we know. And the product is p times xy. See, the same thing that we did in last problem. But the only difference now, well, I would like to get rid of one variable. So from 1 I have y is 7, no, x minus 7. And I'll put this in 2. Then I will get p equals x times x minus 7, right? But now this is a function of x, so let me make it into px. So p of x, the product function, is actually x squared minus 7x. And using a, b, c, a is 1, b is negative 7, and c is 0. Now a is positive, because of that I will have open up parabola, that means this is a minimum, which makes sense. See here, minimum. We are looking for a minimum, so we have a minimum. So how do we get that minimum? Again, negative b over 2a, that is the place where it occurs the x value, and the actual value is f of that one, in this case p of that one. So let's find out. So negative b over 2a equals negative 7 over 2 times 1, which is 2. So 7 over 2. So p of 7 over 2, that is the value we are looking for. So 7 over 2 squared minus 7. 7 over 2 squared minus 7 times 7 over 2. Now, let me double check. Did I do any mistake? I don't think so. No. 49 over 4 minus 49 over 2, right? And then 49 minus 98, so you get minus 49 over 4. So this is the minimum product, and the two numbers that we require are actually, let me write it over here. Two numbers that we require, x we already found 7 over 2, and y, see from 1 from here, if x is 7 over 2, y is actually x minus 7. See from here, y is x minus 7, so x equals this, y equals x minus 7, which is negative 7 over 2, right? Now let's check x minus y. So 7 over 2 minus 7 over 2, which makes sense. 7 over 2 plus 7 over 2, and we get 7. And the required product is this. Now let's investigate a little bit into this problem. So let me erase these things. With using our intuition, without using a lot of mathematics, using our intuition exactly like before, let's keep choosing numbers. The number that I chose earlier was 8 and 1. So the product is 8, the difference is 7, then 9 and 2, 18, and 10 and, you know what, let me do it like this. So let's say 10 and 3. Right, difference is 7 and it's 30 product. 9 and 2, difference is 7 and product is 18. 8 and 1, difference is 7, product is 8, and then 7 and 0, difference is 7, product is 0. And how about 6 and minus 1? See the difference between these two, 6 minus 1, that's 7. Product is negative 6. Now let's see if we keep doing this. Let's see. Let me erase these things. And how about 5 and negative 2? This is product. 4 and negative 3. So negative 12. And at this point, I would like to take this. You see, the minimum product, we found this value over here, negative 49 over 4. And if you simplify it, negative 49 divided by 4, so 12, 48. See, negative 49 divided by 4, 12, 48. 1 remains, so 10, 12.28, 12.25. So we are close in this one. If I go to the next number, 6, not 6, so 3, negative 6, sorry, negative 4. So the difference is 7. 3 minus 4, 3 plus 4 is 7. And again, product is 12. And if I go one more, 2 and negative 5. So negative 10. See, this number start repeating, and next one is 6, and like that. So at first, at a glance, you may think this is the minimum product, but in between that, we have our actual answer 7 over 2, which makes sense. That is 3.5. So the required two numbers are 3.5 and negative 3.5. So I believe after this investigation, you understand much better, because when we say numbers, it doesn't say integers. So if you ask to find the integers, then you have two sets of solution. Sorry, it can be these two, but in between that we have a real number, rational number, being our solution. When you say numbers, it doesn't necessarily mean an integer, right? That was in my first video, very first video. Okay, let's see more examples. The sum of two numbers is 28. Find the two numbers such that the sum of their square is a minimum. Okay, this is a good one. So let x and y be the numbers. See, again, if we try to break down this question like 1 and 27, that's 28, right? Sum of their square is a minimum. So 1 square, 27 square. Now this problem is a little bit challenging, because see, this can be some number, and if you get 2 plus 26 and 2 squared plus 26 squared, another number. So out of all those results, what is the minimum? So let x and y be the numbers. If they are the numbers, first thing we know, x plus y is 28, and let's make into our first equation. And to make our function such that sum of their squares, so x squared plus y squared, this is, let me choose s, because the word sum, you can choose f, whatever. Now what I'm going to do the same thing. I'm going to use 1, get rid of y, 28 minus x, and I will put this in 2. When I do that, I will get s equal, and s of x, because now it's only a function of x squared plus y squared. So y can be replaced by this, right? Now let's actually simplify this. So x squared plus we have x squared minus 2 times 28 times x, so that's 56x, plus 28 squared, whatever that number is. I will leave that for the time being. So we have 2x squared minus 56x plus 28 squared. So my a, b, and c in this function, a is 2, b is negative 56, and c is that large number 28 squared. Again, we don't care about that much, because for our vertex, now a is positive, because of that I have opening upward, so minimum, and which makes sense. Guys, this is one place that you need to check with your problem. If you are getting open downward thing, that means you have done some kind of miscalculation. So we are getting minimum, and problem asking us to find a minimum, so which it makes sense. And the vertex formula is given by negative b over 2a, f of that value. So negative b over 2a, let's find that. So negative, so vertex, negative b over negative 56, which is positive 56, divided by 2a, so 4, and s of that value. So 56 divided by 4, what is that? So negative and negative positive, 1 left, 4, 14. So s of 14. So the required one number is 14, because that's our, here the x value. So x is actually 14, and the other number y should be 14 as well. So this is our result, and find the two numbers. So actually we are done, but if somebody asks you what is that sum, s of 14, you just have to find this. So 2 times 14 squared minus 56 x star plus 28 squared. That is one way of finding it, but there is an easy way. Yes, you can do that, but you can apply it here, because s is x squared plus y squared. You already know x and y are both 14. So let me erase over here. (14 squared). This is the thing that you just need to find. So 14 into 14, you can simply multiply 196, and there are another ways of finding 14 squared. You can even do it in your mind. I'll teach you, but let's finish this first. So from here you can find, so the S max occurs at when x equals 14. So 14 squared 196 plus again the same thing 196. So 400 and 392, right? Now, yeah, now here a simple trick. See, 14 squared, can you, I don't know whether you can. 14 is 10 plus 4 squared, right? So a plus b squared is a squared plus 2ab plus b squared. So in your mind you can do this is 100 and this is 16. All you need is 2 times this. So 2 times multiplication of this. So 2 times 10 times 4, which is 40 into 2, 80. 180 and 16, you get 196. Sometimes for me, there are tricks like that. Anyway, another nice problem. Let's have a look at this. This is a little bit different one now. Read this problem, pause the video and read it. Okay, now, so you may need a little table here. So the price, let's say price. If you did $12, number of rentals. Now this is a practical problem, very practical problem, 36. So after this study, if you increase, so if it is 1250, 2 renters drop down, so 34, right? So 36 minus 2. That's the perfect way of writing. So 34 is actually 32 minus 2, and 1250 is 12, let me drop the dollar sign, 12 plus 50 cents. And if you keep doing that, if you do one more time, so that's going to be $13. That means 12 plus 2 times 50 cents. And here it's going to be 32. That's 36 minus 2 times 2. And the next number, 30. See, this is the pattern you want to understand. So you are increasing now 3 of this increment. So 3 times 50 cents. And your rental is going down by another 2, so 30, but 30 you can write 36 minus 3 times 2. Let me do one more round. So 14 is actually 12 plus 4 times 50, and here 28, that is 36 minus 4 times 2. Now you see the pattern, right? And if you continue and certain, let's say 12 plus x times, x can be any number, so x times that, and the rental is 36 minus x times 2, or 2x. Now the revenue, or the revenue that you get is 12 times 36 in this case, and in this case this number into this number. So you multiply simply this into this, and what we need is actually our function 12 plus, let me use another color, so 12 plus 0.5x or 1/2 x times 36 minus 2x. So this is our profit function or revenue function. So r of x is 12 plus 1/2 x times 36 minus 2x. See, this is the function, and you just need to maximize it. So let's simplify this. So 12 into 36. 12 times 6 is 72, so 7 left and carry over, 7, 12, 36, and 7, 43. So this part, and then you have 12 into this, negative 24x, and this into this, plus 18x, and finally this and this, minus 2 will cancel x squared. So what you have here is, writing in the general form, minus x squared. From these two I have minus 6x plus 432. So a is negative 1, a is negative, b is negative 6, and c is 432, and we don't care about that much of this. Because a is negative, you have opening down, and we have a max, which is nice because we are in the correct path. We are looking for maximum. Now, and that maximum occur, b equals negative b over 2a, and f of that value or r of that value. So let's find out that b, the vertex going to be negative b, so negative, negative 6, positive 6 over 2a2, so that is 3, and r of 3. So what should you charge? So actually this question not asking for this, but asking for this. So what? Well, you have to be careful. Its answer is not 3. I took x to be my increment, or how many times I increase. X is how many 50-cent increases, right? So x is 3. That means that for the maximum profit, I must 12 plus 3 times 50 cents, so that is $13.50 will maximize my profit. Okay guys, I did different kind of examples for quadratic functions, and I believe that will be helpful for you guys. Thank you.